If you have a car loan at 5%, you're not actually paying 5%, you're paying a bit more than that. The reason comes down to compounding interest. So compound interest means future interest is calculated on both the principal and the past interest earned. Let's look at a simple example of a $10,000 principal invested in a 3-year instrument that earns 10% interest, compounded annually. In that case, the first year we would earn $1,000 in interest, calculated as $10,000 multiplied by the 10% interest rate. But the second year, we would earn 10% interest on $11,000. The original $10,000 principal plus the $1,000 in interest earned during the first year, meaning our year 2 interest will total $1,100. And if we repeat the process in year 3, our interest will be $1,210. So the total interest we'll earn over the 3 years is $3,310. In this case, because the interest compounded each year, you could see we earned an extra $310 in interest as compared to an instrument with simple interest, where we'd only earn interest on the original $10,000 each year for a total of $3,000. That extra $310 comes from earning interest on prior interest. And this is the magic of compounding. While I don't think it's ever been verified that he actually said this, you'll often see a quote attributed to Albert Einstein, in which he states that compound interest is the 8th wonder of the world. And while that might be slightly overstated, compound interest is an extremely powerful concept in finance. Now, many instruments don't compound annually. Semi-annual, quarterly, monthly, even daily compounding is common. And this creates a complication, because interest rates are nearly always quoted as an annual rate. So when compounding frequency isn't annual, we end up with 2 rates: the nominal annual percentage rate, or APR, and the effective interest rate we actually pay or earn. To highlight this, let's look at an example of an investment of $25,000 with an APR of 6%, compounded monthly. The first month we calculate interest as the $25,000 principal multiplied by 6% divided by 12, or 0.5%. We divide by 12 because this instrument compounds monthly, and there are 12 months in a year. So this results in $125 in interest the first month. But then the second month we calculate our interest as $25,125 multiplied by 6% divided by 12, and we'll earn interest of $125.63 in month 2. If we continue this process for 12 months, we'll find that over the entire year we earn $1,541.95 in interest, meaning our effective interest rate is 6.17%, which is greater than the APR of 6% because of the monthly compounding. To convert between APR and the annual effective interest rate, the formula is 1 plus the nominal rate divided by the number of compounding periods per year raised to the power of the number of compounding periods per year minus 1. If we plug in our 6% APR compounded monthly to this formula, we get 6.17%. And it's always true that if interest is compounded more than once a year, the effective interest rate will be higher than the stated nominal APR, which is great when you're earning interest, not so great when you're paying it. Remember the car loan at 5% interest rate we teased earlier? Well, unfortunately, if you take out a car loan at an APR of 5%, the actual interest rate you're paying to the bank is 5.12%. And that's compounding interest in a nutshell. The magic of compounding is that we earn interest on past interest, and it's one of the most powerful concepts in both personal and corporate finance.